really where I wanted to be. We're back apart. We're out of the car. We're back in the shop. A startup video. My cold oil pressure was only 40 psi. As soon as the motor warmed up, that dropped down to 15. That's with the melling high volume oil pump installed. So immediately concerned there was a bad clearance. Did I have stock mains on an undersized crank? Gonna plastic gauge a rod and a main. We're gonna plastic gauge those and confirm the clearance is in spec. I've pulled the cam. There's some concerning wear or scoring on journal number 2. It's hard to see, but there's 2 lines scored into that bearing that match these pretty sharp edges of the replacement camshaft that I ordered. So maybe cam bearing tolerance, maybe main bearing tolerance. I think I'll show you guys plastic gauging these bearings and checking the tolerance, or confirming the reading the tolerance on it. Not as good as micing it, but we'll see. I mean, everything, nothing knocked in the bottom end. I did get, so what was happening is it was throwing a code for cylinders 2 and 3 misfiring. I don't think the lifters were pumping up and moving the valves enough. So we're just gonna work on this and see if we can't figure out where the bad clearance is. Alright, so first step in troubleshooting the low oil pressure on this freshly rebuilt 5.3 Gen 4. I'll pull a rod bearing, main bearing cap, a rod bearing cap. We're going to plastic gauge it. So the way this material works is it comes, this is for 1 to 3 thousandths of an inch clearance. You squish this plastic inside between the bearing and the journal, and then you use this little chart to measure how many thousandths of an inch clearance you've got. It won't focus on it. We're going to do that. So first, I'm going to pull the main bearing cap. Let's check our bearing clearance. That was good for it. No harm done. Okay, so now you take your handy dandy chart and you line up, not on the metric side, on the American side, and that looks like 2 thousandths of an inch. So the main bearings are in spec. Tedious. Engine building is tedious. A little score, but nothing I'm going to be too worried about. Do this together. Two thousandths on the rods. So, next step in troubleshooting the low oil pressure cylinder 2-3 misfire is going to be taking a look, pull the camshaft out, start checking cam bearings, look for something terribly wrong. This motor had new camshaft, new cam bearings in it, so I'll put this rod cap back on and then we'll start working on the next step of troubleshooting. So next phase in the low oil pressure troubleshooting, we're going to look at camshaft, bearings, and journals, looking for anything we could indicate a problem. Got the cam out. I was wondering, could this seal be bad or was it cut? The seal, that seal is intact. It is raised, not flattened. This was brand new. I'm not reusing it because I don't trust it now. So this cam bearing, the oil galleys are where they're supposed to be. It's in the window. I checked it with a pick. I don't think I spun a cam bearing. I won't focus on it. But in this second cam journal, there are 2 score marks, heavy score marks, in the cam journal. Chevrolet revised the camshaft to where the number 2 journal has a oiling groove around it, and I think I'm starting to suspect the camshaft that I purchased is the culprit of my low oil clearance. Back in trying to deal with low oil pressure on the Gen 453. Knocked out the cam bearings. May have already shown how much wear just a few minutes of idling caused. This is the Journal 2 bearing. It's the worst. So got a box of the Durabond CH25s. It's going to be what everybody's using. First off, you can see this bearing's much wider, and this oiling hole a lot more forgiving to hit. So we're going to put these cam bearings in the block. Hope that has a really good clearance. Also, I got in my Engine Tech ES 3588 camshaft, and so here's now 3 camshafts. The original OEM unit with the hammered lobes from the lifter collapsing on the AFM system. The Engine Tech camshaft that's going to go into the motor, and then this is an unbranded internet special. So one thing I wanted to show, the reason why I believe this motor when it started had very low oil pressure to the point that the lifters couldn't pump up, was because of poor clearance, undersized cam bearing journals. The OD is too small. Set this down for a second. See me take this off. This cam measures, because it's all washed out with light, but I'm going to tell you it measures 2.163-ish, 2.163. And this cam, that same measurement won't fit. Cam measures 2.167, which is right on the top of the spec for the camshaft. So this will have a better clearance, should result in better oil pressure. Overall, I would say the build quality is a lot better. Here you have, you know, doesn't matter really, but raw casting marks. That looks like rounded off casting flash, which is exactly what that is. You can see the casting line. So like these razor sharp, these surfaces are chamfered. I think this brand of Engine Tech camshaft is probably going to treat us pretty good. So what I have here is my check the bearing ID main front cam bearing. I'm going to use my outside mic set to 2.165, and then what you will do is take a bore gauge and sweep until you get the smallest number, and then have an assistant zero it out. Zeroed, it reads 35 now, but it's set to be 0 at 2.165. So I'm going to sweep and rock inside of this. And if I'm not doing this right, you can yell at me. But I'm going to sweep, and I get the smallest until I get the smallest number. Which is minus 4 thou. Minus 4.5. Minus 4 is the smallest number. So this front bearing is 4 thousandths larger in diameter than 2.165, because that bearing journal is undersized on the camshaft. That gives me 6.5 thousandths, 6 thousandths and 2/10. So call it 6 thousandths of bearing clearance in here. That's 3 on either side of the bearing. 3 is big, I think, for a camshaft bearing. Next steps, having verified that, order a replacement camshaft, order different cam bearings, and we're going to do cam bearings inside of a rotating assembly, hopefully. Cam bearing installation, part 2. So this motor is a fresh rebuild, but it would be a good example if you had a higher mileage engine and you did a cam swap, but you didn't want to do anything with the rotating assembly. It was still good. I've driven all the cam bearings out. What you have to be aware is there's a slot in the side where your oiling hole has to go. So what I've done is, with my camshaft bearings, these are in order in the package, but I confirmed by the part number these end in a -2, and then this one ends -3. So it's going to be your 1, 2, 3, 4, 5. So this cam bearing, you see I drew a line about centered between the oiling holes so that when I'm looking through the motor, if I make this line vertical, this oiling hole is going to hit a slot and have oil, not have an oil restriction. So that's kind of the game plan. I did get, they're not very expensive, but an LS, the 50 whatever something millimeter 2.165 inch cam bearing installation tool. It worked much better for uninstalling bearings than the universal tool did. So what I plan to do is take my magnet, I'm going to lower the bearing down in, come from the side, collect it on the snout of this cam bearing tool, then visually align the mark vertically in the motor, start the bearing and drive it in, and then I'll check with like a wire or a little pick. I'll do put a little bit of assembly lube. My headlamp is dying, so I don't have much light down in the block. Okay, so now you can see this end of my cam bearing tool is down in here. So back this up a little bit like that, and I'll try and sneak that cam bearing through that window. Line it up. Here goes everything. Okay, so got my number 2 cam bearing lined up. I'll pick it up with the magnet. Use the journal to seat it onto the tool. So now the bearing is on the cam bearing tool. So I have my line, reference line, marked pointing vertically in the bore. Okay, just a little bit. Let's start that bearing. One more hit. That bearing is installed. All new. Put a camshaft in. See how it feels. But rotating assembly never had to come out. A little pain in the butt to gauge, but I think we're pretty good. Camshaft time. shaft in, pick him back up. We're going to do a timing set reinstallation. Gone ahead, rolled the motor up, top dead center, timing mark on top. We're going to orient the timing mark down and be one step closer to victory. I don't know if you've just now got here or if you watched anything else I've made, but the first time I put this together seemed to struggle a bit. We'll go ahead and line up, and it's much tighter, smoother rotating than what I didn't know the first time around. Can't be afraid, you gotta make a mistake once in a while. Timing chain going on. Got my timing gear. Go ahead and get my timing points. Hopefully, this is kind of a pain with this tensioner. Could be worse though. Could be dual overhead cams. Bam. Timing set installed. What I have here is this Melling M295 high volume oil pump. This is a rebuilt engine. I'm going to go with it. I had one in it before, but then I had the issues with no oil pressure, so here we are doing it again. It comes installed with a high pressure relief spring, which is red. If you wanted stock relief or bypass, you would put the blue spring in, or if you really want to party, you can put the black spring in, but this is like not the kind of build we're doing. It comes with two different O-rings. You look at what came off of your pickup tube shape. I know that I've got the green O-ring, so that's what we're going to use. You have to reuse the fasteners. So these aren't torqued. I just got it snug And what I'm gonna do is, this may not make a bit of difference, but give that a little crank, buttoning up the last of the reassembly, getting this thing ready to go on the, get it back on the hoist, back in the car outside. So a couple things, have the new oil pump is installed, put on a fresh O-ring, dab ditch tray, and I pointed it out prior, just rehashing things I've already done ad nauseum. Want that to push in, it's not, there we go, that's feeling good. So what happens is you have studs on your main caps, the windage tray bolts to that. Everything looks good. Got a box of hardware. Gotta go get my bolts. I'll put some Loctite on that one. I'm putting the dampener on now. As you can see how misaligned that seal is. If you just run these in tight without a tool or something to center the seal up around the crank, the harmonic balancer, then you will have issues with that seal wearing out and leaking profusely. Seal has engaged. So what I want to do is I want to take, these are snug but not really tight, I just want to spin the motor a little bit. Going in the rear main seal. I believe this works. Sneak this bad boy in here, position. What you want to do is you have this tool, keeps that lip seal from folding over. So when you push this on, you just want to kind of with a purpose. Okay, what I've got here is the pressure relief valve from my oil pan. If you have active fuel management, you have a secondary oil pressure bypass. This opens up at like 55 psi. So one thing I did, because could this have been stuck open? One thing I did verify, I blew this open using compressed air, and then confirmed that the check valve is closing. So now we're going to bam. Time to do this shit. This sucks so bad. So you may ask, what in the world does an oil filter have to do with your oil pressure at idle? And it turns out GM made some kind of revision. Again, I don't know when there was a bulletin about it, and increased the bypass oil pressure rating for the filter is 22 psi. A filter like this, from what I've read, has a bypass pressure rating of 11 to 13 psi. So at hot idle, this filter is bypassing. This oil filter will force or resist the flow of oil, creating a restriction. Restrictions are what create oil pressure, not flow. So I don't know, it's a long shot. Some people swear running the updated filters made all the difference. All right, motor's primed, everything's reassembled. First start, take two. I'm at hot idle temperature, and I have 40 psi of oil pressure at a hot idle. It'll drop a little bit more. I'm convinced it'll drop a little bit more, but I'm reading 201 degrees of coolant temperature and 39 and 40, between 38 and 42 psi of oil pressure. So we're gonna call it a win. Let's put some miles on this thing. In conclusion, did a refresh on this 2007 Chevy Tahoe. It's a Gen 4 Vortec 5.3 liter with active fuel management. Went back all stock, nothing special. Tried to keep this as cheap as possible. Cost, it creeps, it gets away from you, I guess. Moral of the story is, if you're gonna rebuild a Gen 4 Vortec, don't do what I did. Delete the active fuel management, and pay for the tune. You'll be money ahead. If you have to go with keeping the AFM, make sure your lifters come from Delphi or AC Delco. The AFM lifter right now is like $69 each. per lifter. I'm running aftermarket lifters. We'll see how long they last. Car's drivable, it's functional. Again, I trust it. I'll take it places. I'm gonna start driving it, putting some miles on it, shaking it down, see how it does. But I'm hoping, you know, between having improved the cam bearing clearance, check the main rod bearing clearance, put the motor together again fresh, that this thing's going to put a lot of miles on the road and hopefully not give us a whole lot of issues. So, you know, if this video helps you or encourages you, you could do something like this on your own, or don't be afraid to take it on. If it's already broken, I mean, can you really make it that much worse? It's driving now. So anyways, we'll call it a success in progress, and after a few 100 miles we'll know more about long term what oil pressures are going to stay like. I hope, you know, I hope everything's settled in now. It's got about 50 miles on the motor. So appreciate it. Thanks.